Are you afraid of the depths of the universe? Far beyond the limits of our comprehension, the vastness of space, our home, the Earth, is spread out across this vast expanse of space. There are celestial bodies affecting first and other unknown things. Although for many people, space is incredibly beautiful, but for others, he is scary, whether it's thinking or looking at images of liftoff. One can't help but understand this fear. I can feel the horror. His incredible vastness. The uncertainty lurks inside. The mystery of phenomena, the enormity of celestial bodies is terrifying. What exactly does our fear of space come from? Or what we know, or the great void? This is not clear. The fear of space and celestial bodies is called astrophobia. When we think about space, planets are often regarded as havens in chaos and the void. In some cases, it's true, but in most cases, this is far from the truth. Many planets are not only completely uninhabitable, and it's incredibly strange and scary. They're not some cute, soft thing hanging from your crib. The ones that hang from our cribs are mostly gaseous beasts. So desolate, so absurd. Consider the planet Jupiter in our own solar system. Jupiter is a gaseous planet. Its diameter is 11 times that of the Earth. For reference, imagine a grape with a basketball next to it. In volume, Jupiter could hold 1/300 Earths. It's so huge and hostile. If the Earth were to enter the orbit of Jupiter, would be destroyed by the attractive forces of Jupiter. If the Earth collided with Jupiter, will be absorbed and burned by the atmosphere of wood gold, eventually fused into his gas cloud and liquid metal. Even with the most powerful theoretical and technical attempts, explore this planet through the deep, rapidly swirling clouds of gas in the palace. Wind speeds can reach hundreds of kilometers per hour. It gets darker and darker with each step. As the sun is gradually obscured by the clouds, until you finally touch the outside of the stars, diffuse and sink into a planet-wide fiery glowing liquid metal piano. Since Jupiter doesn't even have a real surface, there is nowhere else to go or to stand, and that's just in our solar system. Prior to 1992, humans don't even know if there are other planets outside our solar system. Now, these planets are called exoplanets. It is estimated that there are about 200 billion stars in our galaxy alone. It is also estimated that there may be as many as 2 trillion galaxies in the known universe. That makes about 10 billion a planet. Among these planets, there are countless planets like Earth. There are also countless hellish planets. These planets will make contact with our solar system's planets. For example, HD 1:18:9733 ratio. It is about 64.5 light-years away from our solar system. It looks like a beautiful blue Earth-like planet. Soft ocean swirls on the surface form a marble pattern. It looks like a refreshing Van Gogh. Yet the conditions on this planet are so brutal, heartless and bizarre. Compared to HD 1:18:9733, temperatures can exceed 1090 degrees Celsius. Wind speeds can reach 8,700 kilometers per hour, the fastest wind speed in the known universe. These winds are taking pieces of melted glass across the planet. Visiting this planet will plunge you into a blazing cosmic tornado of countless shards of glass. torn by an almost endless stream of cutting fragments. These are just planets, stars. The beautiful twinkling little dots in children's favorite nursery rhymes. Bigger than almost all planets, and the power is greater. The diameter of Jupiter is said to be 11 times that of the Earth, and our Sun is about 10 times the width of Jupiter. Our Sun is at best an ordinary star. One of the largest known stars, red supergiant Guoti 6, died. Its radius is estimated to be 1,540 times that of our Sun. If this star is located at the center of our solar system, it will occupy Mercury, Venus, Earth. The orbits of Mars and Jupiter. Our Sun can hold more than 1 million Earths, and 5G64 can hold billions of suns. That's trillions of planets. This star is like a small universe of hot gas and energy. Temperatures reach thousands of degrees Celsius, huge and shimmering. When a massive mass like OG64 dies rampant, they form more bizarre, bigger and more powerful. A more threatening existence, perhaps the most incredible and disturbing existence in the known universe. After the star runs out of fuel, the balance of radiation and attractive forces is disrupted. The core will collapse and explore yourself in an instant. Produce a super explosion. If the star is large enough, what's left is a black hole, a space-time region. Such an attractive force. Nothing can escape. At the center of a black hole is a so-called starting point. This is an infinite density, infinitesimal point. All notions of time and space collapse here. Why is the exploration of stars causing this? How could there be a seemingly infinite beginning or recipe in the universe? What happens to infinitesimal matter at or beyond the starting point? Does the starting point really exist? We don't have answers to those questions, but we do. These galactic clusters can grow to incredible scales. Makes even the largest stars ordinary in the observable universe. The largest possible black hole is Swallow 618. The diameter of this black hole is at least 24 billion kilometers, and possibly bigger, because it's still growing. This is roughly the size of 11 solar systems. Swarms of galactic matter are swallowed by this monster. It's as bright as 10 trillion stars. Nothing is bigger than this. This is the incredible void. The cold, barren space that separates everything. Between galaxies and superstar clusters, even the Teng 618 seems insignificant. In general, star space and the space between stars occupy most of the volume of the universe. So-called supervoids are particularly large open areas. Compared to other regions of the universe, there are almost no galaxies or ladders, and there's a terrifying supercavity called the Burt Void. The diameter of the Burt Void is 3.30 million light-years. The diameter of black hole Greedy 618 is about 0.04 light-years. This makes the Burt hole about 8.25 billion times larger than one of the largest black holes in the universe. That's 330 million light-years, mostly cold. 4 seasons dark space. Just think of this vast emptiness. Can trigger a strong sense of oppression and claustrophobia. Worse is the truth. The bottom void and all voids. The entire universe is expanding. Everything is falling apart, including us. It has been moving at a speed we can't imagine. Now, we're not just rotating the Earth and orbiting the Sun. Our own Milky Way galaxy and the group of galaxies to which we belong, it's called the local group, is traveling through space at about 2.08 million kilometers per hour. As the universe continues to expand, eventually nearby stars will come together, and then farther and farther away from the rest of the universe. In the distant future, we will interact with other galaxies and clusters of galaxies, gathered so far away, so much so that they will no longer be detected. No matter what foundation a species has, if humans or any other advanced intelligent species were to exist in these new groups, they will think that the entire universe is just their own mind. They will think that this is the whole universe. Past history and possible history, we can only guess. What are those things that we have no access to? As the famous astronomer Edwin Haber said, as distance increases, our knowledge is fading rapidly. Eventually, we reach the farthest boundary of the telescope, and there we measure shadows, finding landmarks in errors of little substance. At this moment, together with these cosmic beasts, we are floating in a vast uncertainty. There are also Voyager 1 and Voyager 2 star probes. These probes were launched by NASA in 1977. Voyager 1 is the farthest object ever made by humans. There are so-called gold records on these two probes. Gold discs have images on them. The sound of music Earth. Verbal greetings and notes and symbols of record and origin. And if all that about space isn't unsettling enough, consider the fate of these probes. Voyager probes and others may continue to float aimlessly in space for billions of years. If they really float into some distant future, they will be the only remnants of human Earth. Image inside. Sound and technology will no longer point to any species. Even under the theoretically best-case scenarios, humans can walk with these probes forever. These detectors will eventually disappear, and humans and everything else will die with it. Although we can't be sure how everything will play out. But it seems that the universe will eventually come to an end. All energy is finite. Everything is declining. The void is growing. Eventually, a final void will swallow everything. As the author A.P.P. Lovecraft said, I believe that the most benevolent thing in the world is the inability of the human mind to connect everything together. We live on a peaceful island of ignorance, surrounded by an endless sea of black. And we shouldn't have sailed far. Each science fights its own battles. Little harm has been done to us so far. But one day, the result of piecing together scattered knowledge will reveal such a terrifying reality. And our terrifying place in it, so much so that we're either going crazy for being sturdy, or escape into a new dark age. In some ways, one might think that those horrific realities are now known to many of us. Advances in human science, technology, and consciousness reveal a vast, terrible, indifferent universe, and we are an inescapable part of it. The fear of space is not entirely irrational, completely reasonable in many ways. But sometimes the best way to deal with certain fears is to face them head-on. Maybe he's not as dangerous as he seems. Look up at the endless space, burning fireballs and gaseous planets. Look at the endless expansion of the void. you won't devour you again. On a planet that won't tear you apart. You are in just the right place in the universe. Just in time. Just the right size. Let life be born. Evolved and created you. Make you feel alive. This is where Earth is today. In the vastness of the night sky, hidden among countless stars is an amazing scale. Powerful celestial event. These events are enough to swallow an entire galaxy. The impact is felt, the entire universe. What we're going to talk about today is a stellar catastrophe called a superstar. Ancient civilizations regarded these celestial phenomena as good and bad universes, and modern astronomers study them to understand the mysteries of the courtesy universe. Ultra-new exotic beauty and mysterious power have always fascinated. The recently observed deep hues suddenly dimmed, sparking widespread speculation in the scientific community, thinking he might be about to go supernova. If the predictions come true, it will be the brightest superstar explosion observed on Earth in more than 400 years. The journey we are about to embark on, it will take you deep into the disasters of these stars and their impact on our planet, and how they tell the story of our unknown place in the universe. We will explore the tide stars in the universe. It's a cosmic drama featuring stars. Stars are born, life to death. The ultimate performance of certain stars is so spectacular, so that it can illuminate an entire galaxy. Supernovae and the catastrophic end of stars are powerful and bright stellar explosions. In the final stages of a star's life, at this point, the nucleation of the star's core cannot support its outer layers, causing the core to collapse under the action of its own gravity. Trigger a violent explosion. This explosion is bright enough to temporarily blanket the entire galaxy. The energy released by a supernova explosion is tremendous, equivalent to the total energy released by our sun in its roughly 10 billion year lifetime. Supernovae are more than just a fascinating cosmic phenomenon. They play crucial roles in the course of the universe. It is responsible for distributing elements throughout the space. We know that planets and the elements required for life. In fact, most elements heavier than iron, such as gold and foil, are produced by supernew explosions. Therefore, the gold in your jewelry, iron in the blood, calcium in bones, were once part of a star, long before ancient civilizations began to observe stars. A spectacular stellar explosion has already taken place. The ancients recorded these celestial events by drawing patterns of constellations. That's when a new star suddenly appears. We now call them supernovae. One of the earliest observations of Christ was made by Chinese astronomers in 185 AD. They describe a nemesis that can be seen during the day. For weeks, disappeared after about 8 months. The remnants of this supernova detected by the modern telescopic landscape have been named 2CW86. Another famous supernova observation was in 1754. S31054 in the Crab Nebula, recorded by Chinese and Arab astronomers. This nemesis is about 4 times brighter than Venus. 23 consecutive days of daylight. So these ancient observations of superstars had a profound impact on these civilizations' understanding of the universe. Overturned the unchanging concept of the universe. They're also used to read horoscopes and omens. And today we don't look for supernovae just for omens. but to gain a deeper understanding of the life cycle of stars and the creation of elements. Although our understanding of the universe continues to advance, but these stellar explosions still fascinate us with their power and mystery. Recently, a red supergiant in the constellation Nathantheus and Orion has attracted the attention of astronomers. This star, which is nearing the end of its lifespan, began a drastic transformation at the end of 2019, sparking speculation. I think he may soon explode into Kaohsiung. However, his brightness has since returned to normal. The most widely accepted explanation for this phenomenon is that stars emit huge clouds of dust. When the dust cloud dissipates, the brightness of Shengshu Temple returns to normal. But in the process, the dust cloud blocked some of the light, makes the star dim as seen from Earth. This reminds us, the universe is by no means a quiet place. It's a living space. The birth of stars, existence and end play out. Every star that twinkles in the night sky tells a story. The story begins hundreds of millions of years before we saw their light. A star's lifetime is formed from a simple cloud of gas and dust. The transformation process to become a dazzling beacon in the universe. The journey of a star begins in a nebula. Parenting faux pas in these universes, gas and dust begin to collapse under their own gravity. With the collapse, temperature rise, formed a circular perseverance after millions of years. This process continues. As more substances attack from the surrounding mind, the pressure and temperature at its core gradually increase. When the core temperature reaches about 15 million degrees, nuclear fusion begins. Protostar becomes the main star at this time. Like our Sun, these stars can continue to burn in their cores for 11 years during the main demand phase. But eventually the green fuel runs out. The stars will usher in the next stage of their destiny. It depends on the mass of the star. For stars with masses comparable to our Sun, the core will contract and heat up, causing the outer layer to expand and become a red giant. Ultimate core crash. The outer layer is ejected. Formation of planetary nebulae, leaving behind a white dwarf. However, not all stellar endings are so ordinary. Some stars are destined to become tidal stars. This depends largely on the mass of the star and other factors. For example, air supernovae are characterized by the lack of tilts in their spectra. The most famous substar supernova occurs in binary systems. One of them is a white dwarf. He passed from half-galactic matter. Once critical mass is reached, heat and explosion occur. Create a supernova, and AB and SC supernovae. Usually because massive stars lose their outer layers of hydrogen, caused by the collapse of the core in the C meridian. So let's look at a Type II supernova. These are produced by massive stars that are at least 8 times the mass of the Sun. These massive stars spend their lifetimes in the tug-of-war between the attractive force pulling inward and the core fusion pushing outward. But when the core is good, it fuels gravity to win. The core of the star collapses. And this happens in about a second. Triggers a powerful supernova explosion. Explode the outer layers of a star. Create a spectacular scene. Overshadowed the entire galaxy in a short period of time. The remnants of the star could form a dense neutron star. Or if the mass is large enough, It could even become a black hole. But the legacy of stars is the elements that were scattered throughout the universe in these explosions. These elements form new stars. The journey of planets and even life provides the building blocks. When a star goes supernova, this is more than just a visual feast. It is one of the most energetic worlds in the universe. The energy released by a supernova explosion is tremendous, equivalent to the total energy released by the Sun in its 10 billion-year lifetime. And more than 99% of the explosion energy is carried away by neutrons. These almost massless examples are produced in abundance during supernova outbreaks. Travels at nearly the speed of light. The remaining energy is released as light and other forms of electromagnetic radiation, including gamma rays and X-rays. Although the energy is low, but still much more powerful than visible light. Visible poles from stinky stars, for the bright can briefly overshadow the entire week. You can see it even at great distances. This makes supernovae an important new standard for astronomers to explore the universe. Although observing supernovae is a lot of fun, but their tremendous energy and radiation release could also pose a potential danger to the planet. Especially when the supernova is compact enough from Earth. We do have reason to worry. One of the major single advantages is the impact on the Earth's ozone layer. The ozone layer is essential for life on Earth. It's like sunscreen for the planet. Protect us from the sun's harmful ultraviolet rays. However, the intense gamma snake tongues produced by the nearby ultra-new eruption could disrupt this protective cover, causing more ultraviolet radiation to reach the Earth's surface. This increased ultraviolet radiation is harmful to the Earth's biosphere. It may lead to an increase in the incidence of skin cancer in humans and other animals. And they interfere with photosynthesis in plants. This will affect the entire ecosystem. Except for gamma rays, ultra-modern explosions also release high-energy cosmic rays. These particles further damage the ozone layer and produce irritant tumors in the Earth's atmosphere. Increased radiation dose, increasing the risk of supernovae posing a threat to Earth. Attractive force waves are ripples in the fabric of spacetime, produced by violent and dynamic processes in the universe. As predicted by Albert Einstein in his general theory of relativity in 1916, huge accelerating object, like neutron stars or black holes orbiting each other, will produce twisting waves of stone holes when a massive mass collapses and explodes as a supernova. Due to their massive mass and explosive energy, be an ideal candidate to generate these waves. Although the attractive force reaches the Earth very weakly, does not pose an immediate danger, but they offer us a new way to study the universe. A new era of attractive force wave astronomy. Although the probability of Earth being affected is minimal, but it is very important to understand these potential dangers. This reminds us we are inextricably connected to the universe. Events in the universe, even light years away, it could also have an impact on our homes. In fact, supernovae may have played a role in shaping Earth's history. Scientists have found evidence of the iron 6 form in ancient strata and Antarctic ice core. This is a radioactive cupromycin that doesn't occur naturally on Earth. They were created by supernovae, suggesting that Earth once received the remnants of these stellar explosions. A supernova explosion that occurred about 2.70 million years ago may have affected Earth's climate. It may even have caused a period of cooling. There are also theories that superplanets are linked to mass extinction events. It may be because the universe from the supercenter is suspected of destroying the ozone layer. Increased ultraviolet radiation at the surface hurt lives, 4C in particular. Although these theories are still being studied and discussed, but they highlight the possible impact of distant cosmic events on our planet. Remind us, we are all part of this dynamic, interconnected system of the universe. When we look up at the night sky, we're not just looking back. We are also looking to the future. The birth and death of stars will continue. Some of them will end their lives as supernovae. Astronomers estimate that a supernova explodes in our galaxy about every 50 years. But most supernovae are not easy for Earth, because dust and gas blocked our world's last visible supernova. The star explosion was observed by John Reskibler more than 400 years ago. However, astronomers are closely monitoring potential supernova candidates. These include the massive stars in the constellations Orion and Cygnus. These stars are exhibiting unusual behavior. Recent research has opened a new chapter in the mysterious behavior of the celestial superstar, my Deep Zeus. The star has been the subject of close scrutiny by scientists due to its semi-regular variations in brightness. These changes suggest that the brightness of stars does not increase or decrease in a strict cycle. Instead, it exhibits a predictable but not completely regular pattern. The researchers discovered 4 distinct cycles in the brightness of its deep rust filaments, respectively for 2004, 2030, and 185 days. They believe that these cycles reflect rampant pulsating patterns. In particular, the mirror main mode and the first, second, and third reactions. This pulsation analysis solidifies the complex interaction between pulsation and convection, suggests that my deep hues may be in the late stages of core carbon burning. The study also explores the depth of hues, a major event experienced between December 2019 and February 2020. Researchers speculate, during this period, the effective temperature of the deep rusted wire decreases by about 100 K. This may have caused a significant mass ejection from the star. This discovery triggered a series of observations and analyses designed to reveal the secrets of this distant star. The researchers' conclusion is exciting. He is currently in the middle and late stages of burning him in the core. He could be the next star in the galaxy to explode into a superstar. Its high luminosity and complex variations make rust death a prime candidate for participation in this cosmic boom. The study also pointed out that Shenyang Temple, the high autobiographical rate of a red supergiant, has led scientists to an in-depth discussion of its evolutionary process. This includes the possibility that a star may have merged with another star in the past. So we get an assumption of agitation. However, it is worth noting that it's extremely difficult to predict exactly when a star will go supernova. This is not just because he relies on many factors that are not yet fully understood. Even if there are signs of going supernova, stars can also take thousands or even millions of years to achieve this process. But once a supernova actually occurs, an unimaginable astronomical wonder. The study of supernovae is crucial to our understanding of the workings of the universe. The catastrophic end of these stars marks more than just an end. It also symbolizes a new beginning. They set the center of the universe. Stars, and possibly life spread out into space. As we explore this vast and mysterious universe, we're constantly being reminded that superstars are not just part of a star's life cycle. It is also a testament to the interconnectedness of elemental creation and cosmic gold. We study them not only to structure spectacular events, but also to better understand our own place in the universe and how we were born from stellar matter. We are the giant of the universe. It is part of a dynamic and constantly evolving system, and ultra-refreshing research is one way to explore this system.